Lesson 5-6. We're going to look more at radical expressions and simplifying some more difficult radical expressions today. Pay close attention to what we have right here. Simplifying radical expressions, and when radical expressions are in simplified form, we have to make the index as small as possible. The radicand contains no factors other than 1 that are nth powers of an integer or polynomial. That means under the radical. The index is the little root that you're taking. The radicand contains no fractions, so we can't have a fraction underneath the radical. Radicand just means the radical. And no radicals can be in the denominator. That's very key also. So keep in mind as we go through this lesson and work on simplifying some more difficult radical expressions. So if we look at this first example, this kind of ties in a little bit to what we looked at in 5.5. I want to do the square root of the variable part, and of the number part, or the coefficient, and I want the square root of the variable part. So I'm going to separate it kind of like we did in lesson 5.5. Okay. Now, 25 is a perfect square. The square root of 25 is 5. Okay. Now, what I want to do underneath here, okay, last time in the last lesson, the index here is 2. Okay, if you notice, we can do the square root of the a to the 4th, okay, because this is an even exponent right here. If we take the 4, divide by the index of 2, it's a squared. But if you notice, on the b right here, we have an exponent of 9. So what I'm going to do is I'm going to write, so we've already taken care of the square root of a to the 4th, that's my a squared. I'm going to write the square root of b to the 9th as this. The square root of b to the 8th times the square root of b to the 1st. The reason I'm doing that is I can't divide the 9 by the index, or it comes out to be a decimal, doesn't divide out evenly. But I can do the square root of b to the 8th, that's b to the 4th, and I still have a b left underneath the radical. So the square root of b to the 9th is b to the 4th multiplied by the square root of b. Now, if you kind of think about everything we have left right here, okay, so I'm going to look at all of this right here. Now I want to kind of bring it all together here at the end. So I want to put anything that's not under a radical out in front, so that's 5. And then I have a squared, b to the 4th, and then multiplied by the square root of b. So there is the answer to that problem right there. Okay. So we go over here. Now I have a 4th root. Okay, so I'm going to do the 4th root of 16 times the 4th root of x to the 5th, y to the 4th. So I'm kind of separating my coefficient part and my variable part. Now, if you notice, if you refer to your sheet where we gave you your perfect squares and cubes and powers of 4 and things like that, 16 is a perfect power of 4. 2 to the 4th is 16, so the 4th root of 16 is 2. Okay, now if you notice, we have a 5 on the exponent of x. If we go over to the variable part here, that doesn't divide out evenly. Okay. The 4, the y to the 4th, that does divide out. So that's going to be y to the 4 divided by 4, which is y to the 1st. In other words, the 4th root of y to the 4th is y to the 1st. Okay. What I want to do is I want to break x to the 5th down into x to the 4th times x to the 1st, because now I can do the 4th root of x to the 4th. The 4th root of x to the 4th is x to the 1st. So I've kind of taken care of that. And I still have underneath the root, or that multiplied by the 4th root of x. So a little bit better way to write the answer here would be 2, and I'm going to put my x before my y here. So x to the first, y to the first, times the fourth root of x, or x to the first. Okay, now we're going to look at quotients or fractions. Okay, when you're simplifying these, you must rationalize the denominator. And what I mean by rationalizing the denominator, no roots in the denominator. Okay? Now, if you think back to what we did in 5.5, what I'm going to do here is I'm going to separate this into, it's a square root of a fraction. If you think about what we did in 5.5, I'm going to say it's the square root of y to the 8th over the square root of x to the 7th. Okay? Square root of the top over the square root of the bottom. Okay? Now, I can actually do the square root of y to the 8th on top. Okay? But I'm gonna hold off doing that here a second. Notice the 7 does not divide by your index of 2 right there. So what I want to do is I want to multiply by a square root. Okay, I'm not going to put the index on this one, of something, and it's going to be an x there, x to some power, where when I multiply the things under here, I can take the square root of it. If you notice, if I multiply by the square root of x to the first, that's going to leave me with this, the square root of x to the 8th, because I would multiply x to the 7th times x to the first. Okay, and eventually I'm going to, and I'll do that in the next step, that's a perfect square. I can now take the square root of x to the 8th because the exponent is even. Okay, but now if I multiply on the bottom by the square root of x, I have to do that on top. Just like when you're doing common denominator, what you do to the bottom, you must do to the top. Okay, so what do I have left? The square root of y to the 8th, okay, is y to the 4th. So I'm going to have a y to the 4th on top, times this square root of x right here. Okay, and then on the bottom, I'm going to do this square root. So let's get down to our final answer here. I have y to the 4th, square root x on top. The square root of x to the 8th is x to the 4th, taking 8, dividing by your index of 2. So that's x to the 4th, and that's as far as I can go. Okay, I can't cancel anything under the radical with something that's not under a radical or under a root. Okay, if we go over to this one, now we're dealing with a cubed root. Okay, so I'm going to separate this into the cubed root of 2 times the cubed root of 9x. Now we're dealing with a cubed root. 9 is not a perfect cube. It's a perfect square, but not a perfect cube. So I got to rationalize the denominator. I got to get rid of roots in the denominator. So I want to, 2 you can't take the cube root of, but I want to multiply this by a cubed root so that I end up on the bottom with a perfect cube. Now notice you have both a number and a variable. If you go down your perfect cube list, okay, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and down your perfect cube list on that sheet that you were given. Okay, if I can multiply 9 by something and get one of these perfect cubes, and if you notice 9 does go into 27, so what do I multiply 9 by? By 3. Okay, now I have x to the first. If I can get x to the third underneath here when I multiply this times this, then I can take the cubed root of it. So if I notice I got x to the first, so I actually want to multiply by an x squared under there so that I end up with the cubed root of 27x cubed on the bottom. If I multiply the bottom by that cubed root, I got to do the same thing on the top. So when I multiply these two cube roots together, I multiply what's underneath. So it is the cubed root, 2 times 3x squared will be 6x squared. Okay? And that top cannot be simplified any further, so I'm going to write that as the cubed root of 6x squared. But the bottom is now a perfect cube. I'm going to do the cubed root of 27 and the cubed root of x cubed. Cubed root of 27 is 3. The cubed root of x cubed is x. So on the bottom, I end up with 3x. And my answer would be the cubed root of 6x squared on top over 3x. I've rationalized the denominator. I don't have any roots left in the denominator. Alright, now we're going to look at multiplying some radicals. You've done some of this in prior classes in algebra and geometry. Okay, you're only going to be able to multiply things that are underneath the same radical. If you notice, we're dealing with cube roots. Now, I have this 5 out here originally, so I'm going to leave that there. And then I'm going to multiply. I have both 2 cubed roots here. So what I'm going to do is I'm going to multiply the things underneath the roots, or underneath the radicals. So 100 times 10 is 1,000. Okay, a squared right here times a to the first right here is a cubed. So underneath my cube root, I get 1,000 a cubed. So now I want to do cubed root of 1,000, and I want to do the cubed root of a cubed. Both of those are perfect cubes. The cubed root of 1,000 is 10. The cubed root of a cubed, again going back to fractional exponents here, a cubed to the 1/3 power, 3 times 1/3, multiply your exponents, so that's a to the first. So the cubed root of a cubed is a to the first, or a. Now we can't forget about this 5 that was up here, so I'm down to 5 times 10a. 5 times 10a is 50a. Excuse me, so that whole thing simplifies to 50a. We end up without a root on our answer. Over here, we're dealing with square roots. So what we're going to do is we're going to multiply 2ab squared by 6a cubed b squared. 2 times 6 is 12. A to the first times a to the third. Product rule says I add exponents, so that's a to the fourth, because that's a 1 there. And I also get b to the fourth. Excuse me. So, now we're going to separate it into the square root of the coefficient times the square root of the variable part, like we've done earlier. If you notice, 12 is not a perfect square. So what I want to do is I want to simplify or look for a perfect square that goes into 12. If you look down your perfect square list, 4 does. So I'm going to separate it into square root 4 times square root 3. I'm going to take the square root of 4, which is 2. So square root 12 in simplified radical form is 2 square root 3. Now I want you to notice that these over here, because the exponents are even, are both perfect squares. A to the fourth, b to the fourth. If I take the square root, it'll be a squared, b squared. So I have times a squared, b squared. Again, dividing the power inside the radical by the index, because it divides out evenly. Now we kind of got to bring everything together here. There's what we're left with. We're going to put 2 out in front, along with the a squared, b squared, which is not under a radical. That square root 3 has to go at the end. So it's 2 a squared, b squared, square root 3.